Hi, my name is Patrick Tyson, and for my project, I built a sequential neural network to predict the number of fantasy football points a wide receiver will score in any given week. The objective in fantasy football is to assemble the highest scoring team made up of different players from different teams across several different positions. Wide receivers, who are the sample I chose for this project, can score points for every catch, yard, and touchdown that they receive. So the main data source for this project was the NFL Scraper API on GitHub. And I used a data wrangling tool called Alteryx to aggregate the data per game and create a moving 3-game average per player per week, which was then output to a CSV file. I then imported that file using Python through Google Colab, segmented the data into training, test, and validation sets, and standardized it using scikit-learn's standard scaler. Once the data was ready, I then built out a neural network using Keras and TensorFlow with 3 hidden layers, each with a ReLU activation function and an Atom optimization function, and ran the neural network for 50 epochs. I hit my minimum mean squared error of 0.8982 after 5 epochs, and this was my new baseline value. The first improvement I attempted was feature selection, and I used my second technology, random forests, to identify the 13 most important predictors. Now, with those 13 predictors, I reran my neural network on the limited data set and achieved a mean squared error of 0.8919. But that was not really enough of a drop to warrant losing 2/3 of my training data, so I chose not to move forward with the limited feature data set. Next, I needed to tune my hyperparameters, and I used scikit-learn's grid search cross-validation function to identify the optimal hyperparameter values, and I iterated through each of the several different hyperparameters, identified optimal values from each, and incorporated them into an updated version of my neural network. This tuned neural network achieved a mean squared error of 0.8826 on the validation data after 398 epochs, which is an improvement from 0.8982, but nothing drastic. Next, I wanted to train my tuned neural network on the test data that I had set aside until now, and then compare my results. I was able to achieve a mean squared error of 0.8936, which means that the neural network was able to yield similar results on a new data set and is thus capable of learning, but not quite to the accuracy level I'd anticipated. One piece of feedback I received was to determine how sensitive my neural network is to the randomness of the data split. So I used the random seed function to randomize my data set 3 different times, and then ran the tuned neural network once on each data set. My results were 0.8741, 0.9065, and 0.8868. And comparing those to my initial 0.8826, it is clear that my model is insensitive to the randomness of my data splits. In conclusion, I was able to use feature selection and hyperparameter tuning to improve on my results and show that the neural network was able to generalize regardless of the input data. While I did not achieve the accuracy level I had initially hoped for, in terms of moving the project from start to finish, overcoming obstacles, and learning along the way, this project was extremely successful. Thank you.